Welcome to this explainer on technology and data analytics. Look, if you've ever stared at the syllabus and felt completely buried under a mountain of tech jargon, you are definitely not alone. We're going to break down these massive digital frameworks into bite-sized, super memorable concepts so you can walk into that exam room with absolute confidence.
Here's our roadmap for the session. We're covering cloud, mobile, and smart tech, then business information systems, understanding big data, 4 big data strategies, and finally, data analytics and risks. Basically, we're splitting things right down the middle, the hardware tools first and the data fuel second. All right, let's jump right into Section 1, Cloud, Mobile, and Smart Tech. This is the bedrock infrastructure that literally makes everything else we're going to talk about possible.
Think of this as your master blueprint. It shows exactly how disruptive tools, like the cloud and smart tech, funnel directly into high-level information analysis, which then branches out into big data strategies. Keep this flow in your mind. It perfectly illustrates how basic infrastructure acts as the launchpad for top-tier strategic decision-making.
Let's kick things off with the cloud. For your exam, the absolute baseline concept you need is SaaS, or Software as a Service. Instead of going to a store, buying a software disk, and painstakingly installing it on your hard drive, you just rent access to it over the internet. A classic, super memorable example, Microsoft Office 365. You pay a monthly subscription, you get the software. Simple as that.
Now, if we take a massive step up from there, we hit IaaS, Infrastructure as a Service. This is way bigger than just renting software. With IaaS, a company is essentially renting the entire computing architecture. We're talking servers, storage, networking, the whole shebang, all over the internet. Think about Amazon Web Services. They provide incredibly flexible tech infrastructure to huge enterprises, so those companies don't have to buy a single physical server. It's a total game changer.
And rounding out the cloud trio, we have PaaS, or Platform as a Service. Picture this as the ultimate developer's playground. It completely strips away all that messy, underlying infrastructure complexity, giving programmers a ready-made environment. This means they can just focus entirely on what they do best, developing and launching new apps as fast as humanly possible. You really want to lock these distinctions into your memory, because examiners absolutely love testing the borders between these three. Just ask yourself, are you just accessing software? That's SaaS. Are you building on a provided platform? That's PaaS. Or are you renting the core servers and storage? That's IaaS. Visualizing those boundaries will for sure save you crucial marks on test day.
Moving past the cloud, let's talk smart technology. To completely nail the difference between smart devices and the Internet of Things on your exam, remember this. Smart devices anticipate human needs. Think of a smart light switch that automatically flips on the second you walk into a room. On the flip side, the Internet of Things, or IoT, is this massive, silent background network of devices constantly exchanging real-time data without any human intervention at all. Think driverless cars or factory sensors predicting when a machine needs maintenance before it even breaks.
Okay, let's roll into Section 2, Business Information Systems. Let's see how all that tech infrastructure we just talked about builds a rock-solid business foundation.
The absolutely crucial point for your exam prep here is understanding that a business information system isn't just one giant monolithic thing, it's layered. At the very top, you've got Executive Information Systems, or EIS. That's for the strategic apex, the big bosses, doing long-term forecasting. Right below that are Management Information Systems, or MIS, used by middle management for medium-term tactics and budgeting. And finally, at the base, you have Operational Information Systems, OIS, used on the ground floor for short-term, real-time, day-to-day tracking. Keep those 3 layers totally distinct in your head.
Now that the hardware and systems are set up, it's time for Section 3, Understanding Big Data. This is the fuel running through the engine.
Listen, if there is literally only one framework you memorize from this entire session, make it this one. The 5 V's of big data. You absolutely must know these. Volume is the massive, almost incomprehensible size of the data lakes. Velocity is the continuous, rapid-fire flow of that data. Variety means it's not just neat little spreadsheets, it's messy, unstructured stuff like social media posts. Veracity points to the inherent uncertainty and inconsistencies hiding in all that information. And finally, value, because honestly, all that data is completely useless unless you can actually extract meaningful insight from it.
To ground those 5 V's in reality, take a look at Sainsbury's Chief Data Officer, Andrew Day. He perfectly brings the sheer velocity and complexity of big data to life. He talks about capturing 300 transactions per second running through their checkouts. And the crazy thing? He doesn't view that massive volume as a system burden. He sees it as a vast pool of raw opportunity to improve the customer experience and optimize stock. That right there is exactly how top-tier businesses view data.
So, with a solid grasp on what big data actually is, let's move to Section 4, 4 Big Data Strategies, and see how deploying this data actually works in the real world.
This strategic matrix by Parise, Iyer, and Vesset, guaranteed high yield for your exam. It brilliantly maps out big data strategies across 2 very simple dimensions. First, the type of data. Is it transactional or non-transactional? And second, the business objective. Are you just measuring current performance, or are you experimenting to predict the future? Let's break down each of these 4 quadrants really quickly. Quadrant 1 is performance management. This uses your standard transactional internal data to measure current performance. Think back to the BigTco case study from the syllabus. By setting up a centralized data warehouse and some slick business intelligence tools, they could instantly run predefined queries to analyze sales trends across every single one of their bakery locations. It entirely replaced hours of slow, mind-numbing manual reporting work.
Next up, if we move into experimenting with that same transactional data, we hit data exploration. This is perfectly illustrated by that famous retail example you've probably heard of, the use cluster analysis on a group of customers who are buying unscented lotions and vitamin supplements. By analyzing that specific combination of purchases, they successfully generated a predictive pregnancy score. This allowed the retailer to hyper-target their newborn advertising. Wild, right? Moving over to non-transactional data, we have social analytics. This is all about measuring reach and engagement out there on social platforms. A fantastic example here is Virgin America. They once offered free flights to 120 individuals who had high clout, basically heavy-hitting social media influencers. By targeting them, Virgin artificially blasted their brand awareness for a brand new flight route, all without spending a dime on traditional advertising.
And finally, the 4th quadrant, decision science. This uses tools like crowdsourcing and sentiment analysis on non-transactional data to make major strategic choices. Take the bookmaking platform Blurb, for example. They use textual analysis to segment their most valuable customers and optimize their paid search advertising against some incredibly heavy competition. It's essentially about finding the underlying mood and intent hidden inside a massive sea of text.
All right, home stretch, Section 5, Data Analytics and Risks. It's time to address the real-world methodologies and the very real dangers of crunching all these numbers.
On your exam, you need to be prepared to clearly distinguish between these 2 forms of analytics. Descriptive analytics is basically looking in the rearview mirror. It observes past trends using familiar tools like Excel pivot tables to figure out exactly what happened and why. Predictive analytics, on the other hand, is looking through the windshield. It takes that past data and builds complex, futuristic models to anticipate strategic outcomes and forecast exactly what's going to happen next. But listen, as future business leaders, you have to evaluate the risks. Let's talk about a huge one, spurious correlations. Back in 2013, there was a famous Google flu trend analysis that completely face-planted, overestimating flu cases by a whopping 100%. Why? Because Google's autocomplete function was accidentally leading totally healthy people to search for flu remedies. The correlation was purely coincidental, not causal at all. Add in the constant threats of massive privacy breaches and data security flaws, and it becomes pretty obvious why blindly trusting data is super dangerous. As we wrap up this explainer and you finalize your exam prep, I want to leave you with a pretty provocative question. With smart devices constantly predicting our most intimate needs, at what point does brilliant predictive data analysis stop being a strategic advantage and start becoming an unacceptable invasion of privacy? Knowing exactly where to draw that line is what separates an okay manager from a truly great strategic leader. Thank you so much for joining me today. Keep these visual frameworks fresh in your mind, and best of luck on your exam. You're going to crush it.